Hey there, welcome to another coding session with Bangalang, our low-level explicit procedural compiled language. They run code on the CPU and GPU. And in this session, actually, what I want to tackle is that concept of running code on the CPU and GPU. I want to make some changes to that. So at the moment, maybe we can show what we do. If you go to core boomstick, that's where it happens. Actually, whoops, didn't mean to do that. If we open our OpenGL example, yeah, here we go. This is hopefully this is not too hard to follow, but this is a procedure that I'm declaring. And you can see I've got @gl compute shader. So it's allocating it as a compute shader, so it will compile to a compute shader. And then we do boomstick.bang with that. And that's what executes it on the GPU. And if I take this off, it'll allocate it normally and it'll run on the CPU. So on the GPU, there are a few things that you can't do, at least with GLSL, the language we're using, and I'm going to kind of assume that this is a general thing. And I think these sort of language restrictions on the GPU are not such a big deal, because generally, you know, look at this is a very tiny function. Functions that run in kernels, I call these kernels, these little functions. They tend to be very small with just a bit of math and stuff like that. So there's some advanced features that are not needed. When I say advanced, you know, like, for example, in GLSL you can't have pointers, you know. You can't have pointers, there's no new keyword, that kind of thing. Yeah, so I guess you can't specify an allocator when you're inside a kernel. You can't use a pointer. You can't create slices, I'm going to say. Are we going to avoid the slice operator? Yeah, maybe we'll avoid the slice operator. I don't know, we're going to put some restrictions. There might be more restrictions that we don't think of today, but we're going to make a start. Right now, the kind of restrictions we have, they happen during generation. So GLSL generation, there are some in here. I think I did a search for them before. Yeah, if I search for an assert in the generation GLSL. So this is how I enforce things at the moment. So if we go GLSL program. So here, for example, when we're running a GLSL program, we're given a procedure to run, which is, you know, this procedure. And it enforces a few things here, like, you know, it can only have a certain parameters are restricted, and the first parameter needs to be an unsigned 32, a 32-bit unsigned integer and things like that. But these are asserts, you know, so these crash the compiler. So in general, the idea in my compiler is that errors should happen during parsing or type checking. And when you get to generation, you shouldn't need to do any error checks. So this stuff shouldn't happen here. It should happen in type checking. So this brings me to the idea of what I actually want to do, which is that I want to have a special procedure type that I call a kernel. So right now, like a boomstick.kernel_t, that's the type of this procedure. If I go to boomstick and go to the top, here's kernel t. So see, it's a procedure. So I want to actually have its own keyword, kernel, so I can distinguish between kernels and other procedures, and then I can apply some context during type checking so that we know we're inside a kernel, and at that time we can apply additional restrictions to what the compiler allows. For example, don't create a pointer. So the first and most important thing, of course, is that it has to look pretty. I can't remember where this is. Is it languages? It was like file types, I think. File types. Yeah, so I have a Bangalang file type. So if I go into that, keywords. So we want a kernel keyword like this. Okay, apply, okay. And now it has a nice color. That's the most important thing. So the first step we're going to actually make in actual code changes is we're going to make it so you can use the keyword kernel, but it's exactly the same as a regular procedure. That's the first step. So first things first, I guess we need to go to tokens. Now we need to add it. Oh, no, before that even, is it source? No, not source, tokenization. Where am I? Maybe it is token. Oh no, yeah, sorry, it is tokens. It is tokens. So this is where the keywords is. List of keywords. So we'll add kernel in here, so the compiler knows that kernel is a keyword. And we're also going to make a node, a token type. Is it a token type? No, it's not a token type. Sorry, I'm getting confused here. A node type. So when we go to AST, so we have procedure type here. So we're going to make a kernel type to distinguish between the two. And we also have these lists of things, and procedure type is a complex type, so kernel type will also be the same. So we're going to search for this, and everywhere that's used, we're going to just make sure that this is also supported. So like I said, so that kernels can be treated the same as procedures to start with. So we've already done that one. This is creating a procedure, that's fine. This is type name. So here, I guess we can go kernel type, procedure type, treat it the same, but we don't want to just have proc here. Maybe during parsing, and actually parsing is a good place to start. Parsing a procedure type. Where is that called? Yeah, so let's, this is important. So if we find kernel, then we want to parse a procedure type. And we need, like what I was thinking is we can say value equals the value from the token. And we also want to change the type. I think I might do this. And maybe procedure must begin with proc. I think I'm just going to move this up here so we get the token earlier. Proc or kernel. So I took off, previously it was specifically saying it was looking for the proc keyword. Now we're just going to grab any keyword and we're going to say if it failed to get a keyword, or US or proc token value is not proc. If it's not kernel or proc, then we've got an invalid keyword. That's not correct. Okay. Now that we've done that, we can say this is proc token dot value. So this will be, you know, kernel or proc. We'll go into here. So we save that as we go. We don't need to peek the token for this. And actually that would be wrong if we did. And the type is if we're looking at a kernel, then we want kernel type, otherwise procedure type. And this is proc must be followed by, so maybe we go %s, %s, and we can just say node dot value, like so. Okay, I think that's that takes care of parsing. Oh yeah, and the reason I did that now is because, so now that we added the value to the node, we should be able to go just, whoops, oh my god, what am I doing? What is it? Type node. Should be able to just go type node dot value. So that should be proc or kernel. Okay. Let's keep looking for usages of that. AST, I was happy with that. I think. No. So we have another one. I think there's two different ways of getting a type name. Yeah, the type var name now. So this should be very similar. Does it have proc somewhere? Here it is. So instead of proc, we put proc or kernel. Cool. Okay, that takes care of that. Now we go here. These are also things that are not these are getting restricted in GLSL. So like if we use an i8 or an i16 within a kernel, the compiler is just going to crash. We'll see if we have time to add these later. I'm gonna say these are the lowest priority. My god, my typing is all over the place. So we'll just add this here. For now, that's the simplest thing we can do. I'm going to close a bunch of these files, but I'm going to leave this one open because I think maybe we'll come back to that. Okay. This is x86, I think, yeah. I'm not really sure, but I'm just going to treat it like a regular procedure. We'll default to that unless we can specifically see a reason not to do that. Because like I say, the first step was just to treat it like a regular procedure. For member, and it is a procedure. I mean, this is return type, return value required. Yeah, let's just put it in there. I mean, a kernel should never have a return type. That's one of the things we want to restrict. But let's just do this for now. I think this looks like the same thing, So let's take this and do that. Here, we've already done that, of course. This is also the same thing again, so we'll put that there. Interesting that in this case we don't have that other condition, not as member. Maybe with a simple assignment it's not needed. I guess this again is basically the same thing, except now it's LHS node. Making those conditions a bit big for my liking, but what is this? Does not refer to a procedure. If you're trying to call something, it needs to be a kernel or a procedure. Yeah, that makes sense. Here we're making a procedure. Oh, this is when we do a conversion call. So yeah, that is just a procedure. We're applying a default allocator. Yeah, so for kernels or procedures, the default is the code allocator. Yep. Complex primary. That includes the kernel type, which, yeah, down here. This is our type checking for procedures. So let's do the same thing for kernels. This is going to be where we're going to put some of our checks later to restrict kernels, but for now we just treat it the same. And then util. I guess this is, we're saying it's not a procedure, so I guess we would say not a kernel and not a procedure. This is my guess. So what is this? Oh, we're checking if it's a static procedure. So yeah, kernel or procedure. It needs to be a kernel or a procedure to be called a static procedure. Okay, I think that's all the places. Let's just close a bunch of files because we have a ton open. Yeah, I wanted to leave that one open because that could be useful. Try to run that. I'm running the GL, the OpenGL example because it actually uses kernels. So this is a weird error. Let's go to boomstick 30. Okay, it's because I have a variable called kernel. Let's just call it bang kernel. And where else is that? Here. And here. Okay. Interesting. Import does not refer to a procedure. Huh. Did I mess up that? Because that's one of the places we changed. I think that's and. If it's not a kernel and it's not a procedure, then it's not a, yeah. Like, it's always going to be not one of those. Okay. Cannot apply allocator with type proc. Cannot apply allocator. I mean, that looks legit. That kind of looks like what an allocator I would expect it to look like. You allocate a size and you get a pointer back. So that's allocator data type. And it's getting coerced with these. So this looks like a memory allocator. So it should be the same as this. Maybe I'll do format.println that. Oh, not just that, the type name of that, to see what we're comparing it against. Maybe that got messed up, or yeah, I don't know. Just need to add a format import here. So yeah, it looks the same, except it doesn't have proc on it. Because proc is the type node value now. Because allocators we create, I think it's ASTUtil. Oh, we're already in that file. I think it's at the top. Yeah, here's where we create the allocators. So we manually create a procedure type node. And in, that was the one we wanted to keep. And in parsing, we made it so we keep the value now. So it should have a value of proc. Okay. Types kernel that and proc that are not compatible. I like this feature, how it highlights things that are the same. So I can see that it's just the proc and kernel that are different, which is legit. And I want that to be the case. I don't want you to be able to interchange kernels and procedures. There are distinct types. So that looks like a legit error to me. And it's again in Boomstick 61. So bang kernel as a kernel T, which is a kernel, and it's getting assigned to func of this type, which is a proc. So I guess that needs to be kernel also. Hey. And then our OpenGL example is running. So that's cool. Now let's see what we can do about, I don't think we need to edit these anymore, hopefully. But let's see what we can do about adding some restrictions. So there's some restrictions here, but I wanted to start with program, wasn't it? Yeah, there was this block here which has some asserts. So this is where it's saying must not return anything, must contain at least one parameter. The original idea was, if we go back to Boomstick, see here I've said that there's an index parameter and then this. The restrictions here also say the first param must be index U32. So I even enforced the name to be index. That's something I have a question mark around. Do we need to enforce naming equality? I'm not 100% on that. But let's maintain that for now. So what was I trying to say? Oh yeah, but the original idea was like, oh, you could have something like that and have extra parameters because you might have other inputs you want to put in. But now I think it should be sufficient to always just have two parameters to a kernel. One is the index, and then the next is a slice. But it could be some SOA. So an SOA is a struct of arrays, which means that each member of the struct is actually an array. That's just a more efficient memory format for this kind of thing. And that would eliminate the need to have multiple of these, because effectively you have multiple arrays within this. So long story short, I think that means we just need always two parameters. First one is the index and the second one is the slice. And we must not return. Okay. So let's cut that out. And let's go to primary. Type checking a primary, and yeah, we're in kernel procedure. So we do everything. I think we'll do these checks are for defaults. I'm also going to make it so you can't have a default parameter. You know, you couldn't do, where is it, boomstick? You couldn't do that. That doesn't make sense. You can't have any defaults. So we'll add that restriction as well. We'll just let this code run, there's no harm. This is about the return type. So we'll put that before that because we want to stop a return type from happening. So let's say if node.type is kernel type, then we do our checks. So here's a check, we'll just do something like this. So length for the parameters, if it's not 2, we will say kernels must have 2 parameters. And we'll do another check. So we'll say the first parameter, parameters are assignments, because yeah, that's the structure they have. You know, they can potentially, and although I'm saying in this case they can't, in general they can have defaults, so they look like an assignment. So that's how I structure the AST. So then we get the left-hand side of the assignment. This is a bit convoluted. And we get the data type of the left-hand side. And that data type needs to be a U32. So if it's not a U32, we'll say the first parameter of a kernel must have the type U32. And then this is the part that I'm not sure. I've got a note in the to-do to review this. But if we say the left-hand side, the name of the left-hand side parameter needs to be index. The first parameter of the index must have the name index. What else do we want to restrict? Return type, I think. Well, no, the second parameter. So the type of the second parameter must be, well, actually we have like an is slice. So if the type of the second parameter is not a slice, we say the second parameter of a kernel must be a slice. Yeah. Consistently, let's say this must be a U32. Okay. I think that's the parameters. That's already more restrictions on this restriction didn't exist before. I'm pretty happy with that, and we enforce 2 parameters. So now let's enforce, this is checking if there's a return type. So if there's a return type, we say kernels must not have a return type. Something like that. So that will return before we try to do any type checking of the return type. It's pointless for kernels. And there was this defaults thing as well, right? I forgot about that. So let's see if we, I think after we've verified that all the parameters are the right type, we say if, was it default, found default, kernel parameters must not have defaults. Jesus, what was that typing? Okay. Yeah, so we've added a few new tests there. That's good. So I think the current setup should pass. But if we were to go to Broomstick and say, hey, we want to return a U32, it should say you can't do that. Kernels must not have a return type. Okay. What if I say I want to have another parameter, data2? Kernels must have 2 parameters. Okay, and what if I want to make that a pointer to U32? First parameter for kernel must be U32. And if I want to call that index2, must have the name index. And the second one, if I change that to an array instead of a slice, must be a slice. Okay, I think that's good. So kernels are quite restricted in what parameters in the type of a kernel is quite restricted. Good. That's the program one's done. There is also before I get to this, there is also something else I wanted to add. I thought of it while we're in primary. And I've got it on my to-do list. For kernels to disable ref/pointers. Like I said before, you can't do pointers. So I think the way I'm going to do that is I'm going to have some checks like this. So if we reference is like a pointer thing. And I need to add something to the context. So within kernel. And if we're within the kernel and we come across a reference node, that's a bad thing, not allowed. So it's like something like, oh my god, kernels do not support pointers, something like that. So let's add this to the context. Put it at the top because I feel like it's a bigger thing than these others. So within kernel, and then where can we, I think where we can do it is type checking a program. See, this is the loop. So we type check like the main part of the program, and then this is kind of a loop through all the procedures that we're type checking. So at this point we can say within kernel equals, so this procedure statement 0 is the procedure definition. So we get the left-hand side node, yeah, and get the data type of that. And if that is a kernel type, data type.type, I think that's it. That's the statement left-hand side, data type of the left-hand side. So that's a kernel type. That means we're within a kernel. And currently, I think if we try to do, so if we go to GLSL and try to do a call Conversion's not supported. We do support calls. Okay, that's a bit annoying. I was hoping we didn't, because in that case we kind of need to make sure that we know that we're in a kernel. Do we support calls? What do we even call? I'm going to leave this part for now, because I think this will be a more complicated thing. It means we need to, because if from within a kernel, I want to be able to call any procedure we want from a kernel. But then that's like when we do that, it's kind of like a different type checking context to when we normally call a procedure, because now it's part of a kernel essentially, and it needs to be restricted the same. We're going to ignore that for now. Let's put a note. Calling procs from kernels. Yeah, so that should add the context, and then in primary, if we're within a kernel, can't do a reference. Also can't do a dereference. I'm just going to have kernels do not support pointers as well. I think that's good enough. Subscript. This is where I was thinking we should not support slices. We can't define a slice within a kernel. I think that's, yeah, I think that's fair. I mean, maybe it could be possible to do, but I think for now it's nice to just, it's easiest just to say, don't do that. The other thing I was trying to think of was, if you have an array, can you then slice that array and then end up with a slice? No, I don't think so. I think we need to say no to both of those cases for now. So let's go here first, the type case. Oh my God. Kernels do not support slices, we'll just say that. So this is where is a type. So this is where if we're within a kernel and we try to define a slice, we try to create a new variable that is a slice with a slice type, it should fail. And if we try to perform a slice, cannot index type. So this is where it gets a bit complicated. If the child type node is an array, this is creating a slice, it looks like. If it's not a range, so the node in this case is a subscript node, and the second child of it is not a range. Oh, this here, I think this here is telling us that it's a range, so that's why we grab the start and end expression nodes differently. So I think this is saying we're performing a slice now, which is what I don't want to allow. Let's try that. We'll put that up here. Well, we should probably say if within kernel, right? Probably should have kept that part. Okay. So let's try those. Should be fine right now. Yep, it runs. So now if we go to OpenGL and we modify our kernel, let's say we define, like what did we add? So if I define foo is a pointer to a U32, that should be not valid. Pointers, kernels do not support pointers. Great. Likewise, if I say bar equal is a dereference of foo, we'll probably get an error anyway. Oh no, kernels do not support pointers. I mean, I don't know if there's anything you can dereference. I guess data.raw you could technically dereference. Ooh. Oh, I think that was, okay. It just does that sometimes. Which is great. Yeah. So I think because data, like slices are not supported, but also data, the thing that we pass in, is a slice. That's the one place where it can be a slice. So then this would actually be a copy of the slice. Yeah, what happens when you try to do that? Invalid operation. Yeah, it does not like that. Yeah. Can we restrict that? Before we do, let's just see what else was it that we added. That was the pointer stuff, so we also added the slice stuff. So foo is like a slice of data. Kernels do not support slices. Or foo is a U32 slice. Kernels do not support slices. So I think that's all good. It's this thing here. So if we have an assignment, we can't create a slice. Is that what all of these things are doing? All of those slice things so far. I mean, the type 1 is saying you can't define a slice, which is essentially saying you can't create a slice because the way that would show up is like this. The other one was like this, which is also creating a slice. And this is also creating a slice. So I think what we can do is, instead of having these things in the primary, I think we can have it in the assignment. So if we go to, let me just, maybe I do want that code essentially. If I go to type checking an assignment, we can type check the left-hand side, which might not have the type yet. We do the right-hand side stuff, assign that, assignment operator, great. Could not determine type of. Oh, this here is another thing. I wanted to mention this at the start, but I forgot. This is totally an aside, but from the last session, there were a couple of kind of like brute force things, like resolving types, that I got rid of. I don't like it. This is another brute force thing, so it just recursively goes through the ASTL until it finds an array that doesn't use a number literal. So it's a non-fixed array. So I just want to say something more targeted. I don't want this. Is that the right spelling? I don't want this brute force thing, but we won't deal with that right now. But we do want to be an assignment. So I think I was saying like we can go down here. It would always be for a declaration. So we could put it in here. Yeah, let's put it in here. So if we're within a kernel and the LHA, the left-hand side type node has been evaluated to be a slice, then we'll say kernels do not support slices. Run that. Kernels do not support slices. See, so that worked for that, which it didn't work before. If I do that, kernels do not support slices, and if I do that, that's just another way of creating a slice. Kernels do not support slices. Okay, that seems to be more robust. So we have added a bunch of checks. A bunch of checks that didn't exist before for kernels. Now there's some type restrictions. So essentially, this is a bit too permissive, I think. It's kind of saying, oh, there's a couple of specific things that we shouldn't use, but in general, it's just, it'll be fine, which I don't really want. I would rather have this be the default case. Which means we don't need this or this. It's just I32 supported. And I believe, I mean, this should be supported, right? I believe F32 is a float. Is that right? I guess previously it was just going to here, so maybe F32 can be F32. I'm not really sure. If I say blah is an F32, and I compile that, invalid operation. So this is getting the type name for GLSL specifically. So it's kind of converting my type name to the GLSL type name, which I think is probably float. Invalid operation. Maybe it's actually because you need to supply a value. Okay, this is where it would be useful. Like I do have the ability to, export these, what the shader actually looks like. But I haven't done it for a little while, and I can't remember exactly what the best way is to do that. So I'm not going to worry about that right now. This was not in there before, so we're just going to be very restricted. Oh, I think that arrow again was that stupid thing. Okay. So for our current use case, that seems to be right. But that means that when we're in when we're in a kernel, the only types we can use are very restricted. I have to have a bit of a think about where we would do that restricting. Because I guess it would need to happen for assignments, like we were doing before where we said you can't do a slice. That would actually become much more restrictive and basically only allow certain types. But then there are other places where types can appear in my language. They can appear on the right-hand side. So I could say glap equals f32.name or something, or size. That's probably not going to work. Yeah. So this is where we have a type name here, and that could be anything. That could be a slice, or it could be anything, and we don't handle that. So I think we're just going to leave this for now. At least we've got this assertion as a little bit more, enforces a little bit more. That's a good start. So, and eventually I want this to be $T or something, a placeholder. So that could be whatever data you want. It's a bit, it should not be vec4. But the challenge there is that then we need to pass this to this, which means that this type, this is a struct, needs to also be generic, and that's not supported yet. So we'll leave that as it is for now. That I think we can just revert to how it was. Let's have a look in here. So backend specific errors instead of asserts, or kernel instead of proc. I went with kernel instead of proc. And so instead of backend specific errors, it becomes kernel errors. Bounds checking in GLSL. So we disabled pointers in kernels. Bounds checking in kernels, that is something we need to address. Right now, a GLSL kernel will not do bounds checking, but a CPU kernel will, because it just works like any other procedure. I think ideally, I would like to make it so that, if we go to boomstick, so if you do, this is like in this example. So the two parameters are data, which is the slice, and index. And the kernel should be executed in such a way that index is always within the bounds of this slice. That should be guaranteed. So in the case that we do this, if we index into data with the index parameter, we should be able to skip bounds checking. This would be the most common case for indexing in a kernel. I do have the boundless directive. So you can also, for other cases, you can also manually skip bounds checking. So then, so for this case, bounds checking should not happen. If you did anything else like this, then it would bounds check. Even in GLSL, unless you specifically said this is boundless. That's kind of the plan I have. I think that should be, so then it should be a consistent experience in all of Bangalang. But we have this, because we have a bit more context when it comes to kernels, we can make this little optimization. That's the idea that I have. I think in the to-do there was also some more stuff that we took care of. I think it was up here. Yeah, so we have a check now so that it verifies there's not a return. Prevent calling in non-boomstick context. We'll take care of that kind of thing later. So yeah, I think that's it. One last thing, because we do have a bit of time, is I would kind of like to clean up this to-do list. Reorganize it a bit. So I want bugs, issues should be at the top. Let's put test everything at the top of that. And then instead of core features, I want to say like core features, like nice to have features. I guess that would be like dashes, nice to have features, and these things are kind of like dev tools. Yeah, so I kind of wanted to like say, you know, like this is top priority, this is next, then nice to have, dev tools, and stretch goals. I guess we can sort of, I mean, I would, no, let's put that in nice to have, because the core features are the ones that I want to have done before we start a project using this language, which is not actually that many. And down the bottom we have questions. So these are things that I'm like not sure if I'm going to do actually. So let's get rid of that one. Tests. Well, I have test everything up here. I'm not sure what this is about. So I think this covers it. So Windows, Mac, nice to have. Multi-return, multi-assign, nice to have. This is definitely, both of these I think are nice to have, because GLSL, OpenCL would be an alternative way of doing kernels. But I think for now GLSL is fine. Compile time execution, nice to have. I think a lot of these are nice to have, to be honest. These ones, nice to have. I think a map type we should definitely put in. I wonder about these. Let's leave those in for now. Ternary, nice to have. Yeah, okay. And I think a lot of the cleanup stuff, I mean, compiler performance, I guess is a nice to have. I'm going to put it at the top of nice to have, because that's something I would like to do. And then these are all things, I think most of these are things that I want to put in bugs/issues. Let's put it in there. This one specifically would be a nice to have. I'll just call it a partial switch. This is something you've probably seen me use it in Odin. So in Odin, if you don't put #partial before a switch and you're switching over an enum, it will enforce that you have a switch case for each enum value, which is kind of nice. Kind of nice, which is why it's a nice to have. Align for stack files, yeah, I want to have that. Test project in a different folder, that's important. That's, yeah, these I feel like can go in here. Restrict generic param types. I'm actually going to put that as a question. Check if param names. Yeah, this is what I was talking about before when we were when I was saying it has to be index, I'm not sure if this is the case. So affinity of threads, I'm going to put that in nice to have. That's an optimization for our thread pool, because at the moment, each thread in the thread pool could be switching between CPU cores. The scheduler could be switching between, but if we do have it, if we set affinity for each thread, I think what that means is that it's locked to a certain core, and, well, I guess I need to do some more investigation into this, but I think that means that we would have less core switching overhead, I think. Because in the case of our thread pool, the idea is that we have one thread per core, so it makes sense to lock each one to a core. Okay. What else we got to clean up here? Through parsing, deferred type resolution, calling procs from kernels. Yeah, these are all things we need to clean up. And this stuff, I want to clean up the output. Yeah, this is kind of all to do with cleaning up output. I think this is why I grouped them together. Yeah, removing some unneeded assembly and stuff like that. Let's put that in there. There's a kind of compiler cleanups. Well, this is a feature. Actually, this one I'll put in nice to have. This is where, you know, like if you, I guess it's not even really needed that much in my language right now, but like I use it in the compiler a lot in Odin. You can use the underscore when something is returned. If you're returning multiple things from a procedure, one of those return values, you can just give it the variable name underscore, and that's like saying, I don't want to give this a name, so don't worry about it. I would like to have that. This stuff we should do. Let's put that in here. And these are more questions. Okay, so we have a bunch of questions that's not so important. Dev tools. Dev tools I'm actually going to put up here above nice to haves. I feel like that's an important, like if we're going to do projects and if we're going to do other projects with this language, it would be nice to have a level of comfort in doing so. And there's, I mean, debug I feel like would be a difficult one. Docs is just a bit time consuming, and really for me it's not important. Like if I'm coding, I built the language, so I know the language, it's not a big deal. LSP and tree sitter would be really nice for the developer experience and not as hard. LSP, I might actually create a new video series for that. So core features, so it's mostly this kind of bugs and issues stuff that I want to rectify. That's quite a decent list. And the core features is not much. I'm not even sure that this is really, that these are really, really so needed. I think a map would be really nice, and this is almost nice to have. So yeah, I think this one would be really cool. But yeah, I'm actually kind of surprised that core features whittled down to so little. It's mostly fixing up bugs and issues that I want to do. And some of these things are kind of trivial, like they might take a bit of time, but they're kind of trivial. And then we can move on to doing some other projects. That's cool. All right, I'm quite happy with what this has shown me by organizing it this way. Great. So with that, I think it's enough for today. So have a good one. Thanks for stopping by, and ciao for now.